The Frank-Starling curve represents the relationship between the ventricular end diastolic pressure, represented on the horizontal axis, and the stroke volume, represented on the vertical axis. As left ventricle end diastolic pressure increases, stroke volume, and thus cardiac output, progressively increases. This relationship is based on the structure of the sarcomere. At low left ventricular end diastolic pressure, the sarcomere is minimally stretched. The actin filaments excessively overlap the myosin filaments, including the H zone, which lacks myosin heads and is incapable of generating force. Increasing sarcomere length, up to a point, increases the overlap area between actin binding sites and the myosin heads, allowing for a greater recruitment of force-generating cross bridges. In this part of the curve, which is where the left ventricle normally functions, the relationship between force production and end diastolic fiber stretch is near linear. As left ventricle end diastolic pressure increases further, the curve flattens out such that each incremental increase in left ventricular end diastolic pressure results in a reduced increase in stroke volume. This occurs due to loss of overlap between the actin and myosin filaments at high stretch states. In systolic heart failure, decreased contractility results in a reduction in the initial slope and a right-shifted curve. As a result, the force generated at any given filling pressure is reduced, requiring a higher filling pressure to achieve the same cardiac output. As systolic heart failure progresses, a decline in the cardiac output at any given filling pressure can be seen, with a flattening of the curve correlating with the heart's failure to appropriately increase stroke volume.